In this video file, we will be discussing some applications of normal distribution. Now, so these questions are selected from your homework 13. So hopefully this will help you to finish homework 13 quite well. Okay, so we'll start with the first question. Okay, here it says that the graph to the right indicates IQ scores of adults and those scores are normally distributed. Okay, it says normally distributed, it is not standard normal. Okay, so we cannot use this table straight away. Alright, let's continue to read it. Normally distributed with mean 100 and the standard deviation of 15. So we have to find out the shaded region. So basically this area equals to the probability that the IQ score is less than 85. Alright, so let's first okay, so let's write down what we have here. So we have a normal distribution. Alright, now let's see, here's the normal distribution. Right, now here's your x. Alright, now x. Now what is x stand for? X stand for IQ scores, right? So it says IQ scores. So IQ scores. Alright, now now these IQ scores is the random variable. Now this random variable has this normal distribution with the mean equals to 100. Okay, see here, and the standard deviation equals to 15. Okay, so here is 100. Okay, so basically you need to find out the probability that someone's high IQ score is less than 85. Okay, so here's the shaded region. Okay, all right. Now, as I explained in the previous presentation, that we can standardize each of these IQ scores to a standardized numbers, right? So let's do that first. Okay, so what I'm going to do is I'm going to convert each of the IQ score to a standard normal curve. Okay, z. Okay, right, now how we do this? We do this using this formula. So what is the formula? Z equals to x minus mu over sigma. So what is the mu here? So the mu is 100. So mu here is 100 and standard deviation is 15. Okay, right, now so 85, right? So we have to convert this 85 to a z value. Okay, so how will we do that? So x equal to 85, what's going to be the z? So z score of 85 equals to how? So x is 85 now, so 85 minus 100 over 15. Right, remember this is the x, so x becomes 85. So what the equivalent z equals to? So we replace x by 85 here and then find out the z value. So what is that equals? So use your calculator. Now make sure that you convert this into two decimal places. Okay, so 85, I'm going to use my calculator as I speak, divided by 15, so I get -1. So let me write it like -1.00. Alright, right, so that -1.00 is somewhere here. Now remember, in the standard normal distribution, the 0 is in the middle. Alright, now from that theorem that I explained in the earlier presentation, that the area of the normal distribution is same as area under the converted standard normal distribution. Okay, so therefore these two shaded regions are equal. So this is same as that. Okay, so now we will find out this shaded region using the standard normal table. Okay, so we will open the standard normal table. So we are trying to find the area to the left of -1, right? So all these areas given are left, right? Areas from the left. So first we locate the first two numbers, right? First two digits, as I explained previously. So first two digits like that, right? -1.0, so -1, so we locate -1.0. So it's on the first table, -1.0, this one. Okay, and the last digit is 0, so this is like 0.00, right? 0 is like 0.00. So this is -1, and this column is 0.00. If you want to check, see 0.00, it is -1.0. So the z value is this. So sorry, the probability is -0.1587. Okay, so that area is 0.1587. So this area, is 0.1587. Okay, now from the theorem, this area equals to this area, so this area also equals to 0.1587. Okay, so that's the answer. So let's type it and see. Okay, so it's asked us to find out the shaded region in the question. So the answer is 0.1587. Oops, something went wrong. What is it? So let's double check it again. Oh, this is a different question, I'm sorry. So we were actually looking at, I'm sorry, so we were looking at this question. So this is is it 85? Just double checking it. Okay, it is 0.1587. Yes, 0.1587. Let's hope this is right. Yeah, it works. Okay, so the next one that I want to discuss is this question. Okay, so let's erase that. Okay, now we have a shaded region in the normal distribution, and this shaded region is in the middle. Okay, so how we are going to find this area or find this probability? Okay, right, so let's open this note. Okay, so first let's draw the normal distribution. Okay, here's the normal distribution. Here's the x. Now what is x stand for? X stand for, again, IQ scores. Okay, now what is the mu and the sigma for this distribution? Mu is, well, again 100, and the standard deviation is again 15, so here is your 100. Okay, right, now we'll mark 80 and 125. So 80 is right here and 125 is right there, so we have to find out the area between. Okay, so this is the area that we are after. So in terms of probability, you can explain this as this, right? So the probability that the IQ score is between 80 and 125 is the one that we want to find out. Okay, so now what is the next step? The next step is to convert each of the x values to equivalent z values. Okay, so let's draw the standard normal distribution z. So 0 is in the middle, right? So how we gonna convert? We convert using this formula, right? Z equal to x. So what is that formula? Z equal to x minus mu over sigma, right? Now the mu here is 100 and the sigma is 15. So we need to convert 80 as well as 125 using this formula. Okay, so let's first convert 80. Okay, z score of 80 equals to, so x become 80, right? 80 minus 100 over 15. Again, you convert into two decimal places, so 80 minus 100 divided by 15, which is negative 1.33. And similarly convert 124, so z score of 125 is 125 minus 100 over 15. Okay, so that is 125 minus 100 divided by 15 is 1.67 if you convert into decimal, two decimal places. We can round off to two decimal places. Okay, so negative 1.33 is right here and positive 1.67 is right there. So the area that we are after is this. Okay, so how are we going to find this area? So first, as we talk about this a lot in the previous homework, so first we have to find out the area to the left of 1.67, subtract the area to the left of negative 1.33. Okay, so I'm gonna repeat it. Here's your standard normal, here's negative 1.33, here's 1.67, and this is the area that we need to find. Okay, so this is equals to area to the left of area to the left of positive positive 1.67, all of this, minus area to the left of negative 1.33. Okay, right, now we use this table. First we find out the left of 1.67. Okay, so 1.6 and the 7, right? So 1.6 we have to use the next table. 1.6, where's 1.6? Okay, 1.6 and the 7 is up here. Okay, 1.67 is, let's go up and then that's the one, right? Yeah, this one, 1.67. Okay, that is 0.9525. So let's write it down. So this is this area is 0.9525. Right, and similarly we have to find out this area, so area to the left of negative 1.33. So the negative table, 1.33, the 1.3 is here and the 3 is right there, so 1.33 is this one, or below that, 0.0918, right, 0.0918, 1.33 right here. Okay, 0.0918. This is 0.0918. Okay, so this area is 0.9525 minus 0.0918. Okay, so let's subtract this. So what do you get? 25 minus 0.0918. So I got this as 0.8607. Okay, so that is your answer. So therefore this area is what is it, 0.8607. So this area is 0.8607. So that's the answer. Let's type it in and see. 0.8607. 0.8607. Okay, it works. Alright, now the next question that I would like to consider is number 5. So number 5 is, let's see, number 5 is, okay, this one. Okay, this one. Okay, again, something related to IQ scores. So we have to find out the X here. Okay, now as opposed to the previous example, the X values were given. We had to find the area. Now here, the area is given. We have to find the X value. Okay, so let's do this one. Okay, let's open a new page. Okay, and let's draw this whole thing. If you just follow these steps that I'm explaining, you will minimize making mistakes. Okay, but once you feel comfortable with this process, you are welcome to find out the answer straight away. But I encourage you to follow these steps initially. Okay, so first we have normal distribution, that is your X. So again, X stand for IQ scores. Okay, and the mean equals to 100, standard deviation equals to 15, so 100 is here. Okay, now they have provided the area and we have to find out the X. So this area is equals to 0.8. okay, and you got to find the X value. So how would you find the X? So you need to find this X value. So that is what we need to find. Okay, so like before, we actually go from the standard normal distribution, right? So here's the trick. So we're going to draw the standard normal distribution. Z. Okay, 0 is here. Now remember, the area of a standard normal distribution is equal to the area of a normal distribution. So therefore you have this area in the standard normal distribution equals to 0.8. okay, and then we will find out this Z value. Okay, so we will get this Z value and then we will convert this Z back into X. Okay, so that is the idea. Now, do you remember how we converted X into Z? Well, we converted X into Z using this formula, right? X minus mu over sigma. Now, if Z is given, how would you convert Z back to X? Well, all you have to do is you need to solve for X. So you first multiply by sigma and then add mu. So how do you get the X? X equals to mu plus Z times sigma. So here's another formula. Okay, so if the Z is given, you can find out the X using this formula. All right, so first let us find out the z value correspond to the right tail area of point 8, right? Now let's look at the table. Okay, unfortunately these two tables are areas from the left. Okay, but the problem we have is the area on the right, so we have to find out the left area. Okay, so this is point 8, so therefore this particular area which is on the right, on the left, is point 2 because the total area is 1. Okay, now we do have a left tail area, and then which is, now we need to find the z value. Okay, so we look at point 2. Okay, number closer to point 2 in the middle of the table. Okay, point 2, where is point 2? Okay, so point 2s are here, I can see. Okay, the point 2 is between this number and that number, right? Now you have to find out the number closest to point 2. Now the number closest to point 2 is obviously this number, right? You find the difference between point 2 and point 2005 and point 2 and 0.1977. You will notice this is the closest number to point 2, so we're gonna pick the z value of this area. Okay, what is the z value of that area? So negative 0.84. okay, negative 0.8. This number is on the negative 8 row and 0.04 column, so therefore the z value is negative 0.84. okay, so this is negative 0.84. let's double checking it. Yeah, negative 0.84. all right, great. Now, so we have the z value. Now we need to convert this z value into an x value, right? So we have a formula here. So how we do this? So x equals to, now the mu for this problem is 100 plus, what is the sigma? The sigma turns out to be negative 0.84 times, what is the mu? Sigma is 15. Okay, so let's multiply and find this out. All right, so I'm just using my calculator as I speak. Okay, plus 100, so that is 87.4. so this x is 87.4. okay, so let's type this and check the answer. 87.4. yeah, okay, 87.4. works. Okay, now the next one I want to discuss is number 6, this question. Okay, now it says assume that adults IQ scores are normally distributed with mean 105 and standard deviation 20. Find the probability that the randomly selected adult has IQ less than 141. okay, so first you have to draw this whole thing using the normal distribution, because it says that the IQ scores here, IQ scores are normally distributed. okay, so here's your x again stand for IQ scores. okay, right, now so what now, the mean is equals to 105 and standard deviation equals to 20. so here's your 105. okay, so what is the question? The question is we need to find the probability that the x stands for IQ score, right? Probability that the IQ score of an adult is less than 141. So this is what we are after. Okay, now the probability equals to the area. So here's your 141. So that area is this. Okay. All right. Now, first we convert this to a standard normal distribution. Z 0 here. So how are we going to do this? So z equals to x minus mu over sigma. So for this example, x minus 105 over 20. Okay, so if we have to convert 141 to a z value. So z score of 141 equals to, what is it? So 141 minus 105 over 20, right? So let's find this value. So 141 minus 105 divided by 20, so it is 108, 1.8, sorry. Okay, 1.8. Now so 1.8 is right here. Okay, so this is the area that we need to find. Okay, so how we find this area? So it is a left tail area. It's already a left tail area, so we can refer the table straight away. So 1.8, so 0.8, right? 0.18, I'm sorry. Okay, is it 0.18? Yes, no, 1.8. Yes, 1.8. So 1.80, right? So 1.8 is here, 0 is there, so that z value, so the area is 0.09641. Okay, 0.9641. So that is 0.9641. 9641. So therefore this is 0.9641, and that should be the probability. So this probability is equals to 0.9641. So that is the answer. So let's type and see what we get. 9641. Okay, 0.9641 works. Okay, the next one that I want to discuss with you is number 8, not this one. This question right here. Okay, assume, again, an IQ score question. Okay, it says assume that adults have IQ scores. Okay, adults have IQ scores that are normally distributed with mean 102 and standard deviation 15. Find Q3. Q3 stand for 25th percentile. Okay, so let's first draw this. Okay, so okay, so again an IQ score question. X is IQ score. Okay, and the mean is equals to 102 and the standard deviation is 15. So here's 102. Okay, it says we have to find Q3. What is Q3? Q3 stands for the score separating the top 25% of the other. Okay, where is the top 25%? Well, the top 25% is somewhere right here, right? The best one. So 25%. So the area is given. So this area is, all right. So what is that area? 25% means what? 0.25. So that area is given as 0.25, and this x value is the one that we are after. So this x value is the Q3. Remember Q3, the 25th, actually the 75th percentile, not 25th percentile. Q3 is the 75th percentile. 75th percentile is the value that separates the top 25% from the bottom 75%. So these percentages represent the area. So you convert these percentages to decimal forms. So such in that way we can find out the areas can be given. So the areas are found, and then we have to find out the x value, right? So same as the previous question. So first we'll draw the standard normal. Okay, here's a standard normal. Z 0. Okay, here's your 25% or 0.25, and we have to find out this z value. Okay, and then we convert this z value to an x value, and then we have the answer. Okay, so now we have a right tail area, so we need to find the left tail area. So 0.25, the total area is 1, so therefore this area is 0.75. Okay, so that area is, so this area is 0.75, all of this. Okay, now so we locate 0.75 on the table, so it must be on the second table. 0.75, 0.75 is closest one if you don't have the exact one. Okay, 0.75 is between 0.748386 and 0.7517. So which is the closest one? So if you find out the difference between 0.75 and this and 0.75 and that, so the difference between 0.75 and this is 0.0017, and the difference between 0.75 and this one is 0.0014. So therefore this number, this highlighted number, is closest to 0.75. So therefore the z value is 0.67, right? So 0.67 is the z value. So 0.67, so this is, the z value is 0.67. Okay, now we have to convert this 0.67 to x. So how we do this? So we have a formula which is x equal what, mu plus z times sigma, right? So for this example, the mu is 102 plus z is 0.67 times sigma is 15. Okay, so let's find this value, 0.67, 15, and add to 102. Okay, so we get 112.05. Okay, so let's see how many decimal places that we need to round off. Okay, so here it says round off to 1 decimal place. So so what's the answer? So it is 112.1, right? So 112.1. Yes, good. Okay, that's number 8. Now next I want to discuss number 10. Okay, let's look at number 10. Done. Number 10 here, this one. Okay, let's see what this says. Okay, survey found that women's height are normally distributed with mean 63.6 inches and standard deviation of 2.2 inches. The survey also found the men's height are normally distributed with the mean of 68.1 inches and standard deviation of 2.7 inches. Complete the part A. Okay, so So first okay, for the most of the live characters at an amusement park have height requirements, so with the minimum of 4 feet and 9 inches and the maximum of 6 feet and 2 inches. Find the percentage of women meeting the height requirement. Okay, so we first need to draw the normal distribution and convert these two numbers into standard normal distribution, and then find out the area. Okay, so the same as before. Okay, first we have to convert, we have feet and the inches, right? Feet and the inches, so we have to convert feet into inches, right? So let's first do that for, okay, so let's do that first. Okay, so first we have to convert feet into inches. um, right, so okay, let's draw the tables. So let's draw the normal distribution. So here's your x. Start with the x. Okay, the part A is about the woman, so we'll start with woman first. Okay, so this is for the women's. Okay, so x is the, is it the height? Yes, it's the height. Okay, now the mean is equals to 63.6 inches and the sigma equals to 2.2 inches. Okay, right, now we have to find out the percentage of women between 4 feet and 9 inches and 6 feet and 2 inches. So we'll have to convert. Okay, we have to convert 4 feet, so 1 feet equals to 12 inches, so 4 feet is 48, right? 48. So 48 plus 9, right? So plus 9, so 4 feet and 9 inches, right? So we need everything in terms of inches because the units of measurement is in inches. So that is, so 4 feet is like 48 inches and 9, which is 57, right? So 57 inches. So 57 is here. So similarly, 6 feet and 2 inches. So 6 feet and 2 inches, right? So 6 feet, so 1 feet equal to 12 inches, so 6 times 12 is 72 plus 2, which is 74 inches. Okay, so here is your 74 inches and in the middle is the 63.3. Okay, it's the 63.6, I'm sorry, it's the mean. Okay, so it says most of the, okay, find the percentage of women meeting the requirement. So if somebody needs to, if somebody is if somebody is meeting the requirement, then that the woman has to be of the height between 57 inches and 74 inches. So that percentage comes from this area. Okay, so that is what we need to find. So first we convert this to a standard normal. Is our standard normal z, zeros here. Okay, so we first need to convert 57. So how will you convert 57? So z equal 57 minus 63.6 over 2.2. So what is that equals to? So 57 minus 63.6 divided by 2.2. so I get negative 3, right, negative 3.00, and then we have to convert 74, right, so 74, for 74 it is 74 minus 63.6 over 2.2. Okay, let's do this. 74 minus 63.6 divided by 2.2 is converted into two decimal places. I'm gonna get 4.73. Okay, so 4.73 is here. Okay, so the area that we are after is this one. Okay, so we have an area in the middle. So first we need to find the area to the left of 7.37 minus area to the left of negative 3. Okay, so I will be real quick here because I have done a lot of examples of this type. So let's first look at the table and get 4.73. okay, so 4.73 says, okay, 3.5, this table goes up to 3.5, so it says 3.50 and up is 0.9999. so since 4.73 is greater than 3.5, so we have to assume it is 0.9999. so that area is 0.9999 minus, okay, and also we need to find the area to the left of negative 3. okay, so negative 3, let's see, negative 3 is on the other table. Okay, negative 3 is right here, like negative 3.00, which is this number, 0.0013. okay, minus 0.0013. okay, so let's find this. 0.9999 minus 0.0013, and that makes 0.9986. so this area is 0.9986 in the standard normal distribution, therefore this area is also 0.9986. so the question asks about the percentage, so 0.9986 is as a percentage equals to, what is it, 99.86, right, so the answer is 99.86%. okay, so let's type this and check our answer. Works. Second question, find the percentage of men meeting the high requirement. okay, so now we have to redo the same question, the same thing for the population of men. okay, so let's open a new page. so now we're gonna do the same thing for the men. okay, now this is for men side. For men. okay, so we have a normal distribution, so x is equals to the height. okay, now for men the distribution has the mean equals to, okay, says the men's height are normally distributed with 68.1, so 68.1 inches, and the standard deviation is 2.7 inches. okay, right, so here's your 68.1. okay, now the requirement is to be between 4 feet and 9 inches and 6 feet and 2 inches. so we converted 4 feet and 9 inches into inches in the previous part, which is 57. so here's your 57, and 6 feet and 2 inches into inches is 74, right, so yes, 74. Okay, so we are talking about this one and this one. Okay, see, we converted 4 feet and 9 inches, 457 inches, 6 feet and 2 inches, 74 inches. Okay, now so we have to find out this area. Okay, so same as before, we convert into standard normal. Okay, it's just a reminder that the standard normal, how will you do that? X minus mu over sigma. Okay, so first we have to convert 57. So what is this? 57 minus mu is 68.1 over sigma is 2.7. Okay, what is that equals to? 57 minus 68.1 divided by 2.7, which is negative 4.11. Okay, this is negative 4.11. And then similarly 74. So 74 minus 68.1 over 2.7, what is that equals to? 74 minus 68.1 divided by 2.7 equals to 2.19. Convert into 2 decimal places. Okay, so that is 2.19. So we need this area. Okay, so just like the previous example, first we will find the area to the left of 2.99 and subtract the area to the left of negative 4.11. Okay, so we will first find the area to the left of 2.19. So 2.19 is 2.19, the next table. 2.19, 2.1 is here, so the 9 is way here. So 2.19 is this one, no, 0.9857. okay, 9857. Okay, so 0.9857 minus and then we need to find the area to the left of negative 4.11. okay, negative 4.11. okay, well, it starts from negative 3.4. it says negative 3.50 and lower. Since negative 4.11 is less than a negative 3.50, so we have to assume that area is 0.001. okay, so minus 0.0001. okay, so if you subtract that, you're gonna get it as 0.9856. okay, so 0.9856 is the area of the standard normal distribution between these two values, so which is exactly the area of the normal distribution between 57 and 74. so this is 0.9856. so as a percentage, how many of them are qualified? 98.56. okay, so let's type this and check. Oops, 98.56. okay, let's double check that. Yep, works. okay, if the height requirement are changed to exclude only the tallest 5% of men and the shortest 5% of women, what are the new height requirements? This is a tricky question. So it says now they're going to change the height requirement so that they will the maximum height comes from the tallest 5% of men, and the minimum height comes from the shortest 5% of women. Okay, so we had to find out those two values. Okay, let's first we will find out the maximum height. Okay, so the maximum comes from what? Maximum, the tallest 5% of men, right? So we start with the men. Okay, because the maximum height comes from the distribution of men, right? Tallest 5% of the men, so we will use that distribution to find out the maximum height. Okay, this is the men's height. Okay, so the men's height, so what are the mu? So for the men, the mu is 68.1 inches and the standard deviation is 2.7 inches. So the tallest 5%, so where is the tallest 5%? Here is the tallest 5%. So that area is equals to 0.05. Okay, I should use a different color perhaps. Okay, so that area is, so this area is 0.05 and we have to find out this x. Okay, so now we convert this into standard normal. Okay, so in the standard normal you have 5% here, this is 0.05, so we have to find out this z value. Okay, so since it's a right tail area, so the left tail is 0.95, so we have to find out the z value corresponding to the left tail area of 0.95. okay, so look at the table, 0.95. I think 0.95 is a special area. It says 0.95 here, right here. So the area is 1.645. Okay, you can see 0.95 is right here in the star. So that the z value is, it's given as a special z value 1.645. So that is, this is 1.645. Now we convert this z value to a x value. How we do this? So we have a formula, x equals to mu plus z times sigma. Okay, mu is 68.1, this one, plus, and the z is, well, we just found out 1.645 and the sigma is 2.7. okay, what is that equals to? 1.645 times 2.7 plus 68.1, which is 72.54 inches. Okay, so the maximum height requirement is 72.54. now we have to find the minimum height requirement. Okay, the minimum height requirements come from the population of women. Okay, the minimum, oops, okay, the minimum height comes from women's yeah, we have, where is it, yeah, this one, right? So for the women's distribution, I would say women's height distribution, huh? So we will use that normal distribution to find out that minimum height requirement. Okay, so X stands for women's height. There you go. Okay, so let's look at the question again. It says the shortest 5%. Okay, where's the shortest 5%? So the shortest 5% is right here. Okay, so we have to find, okay, so this area is 5%, so 0.05. We have to find out this X value, that which is the shortest, which is the minimum height requirement. Alright, now we have the normal distribution, standard normal distribution, Z. Okay, somewhere here is the 5%, 0.05. Now, which is already a left tail area. Okay, so we have to find out this Z value. Okay, 0.05. Okay, 0.05 is a special. See, 0.05 is here. So the Z value is negative 1.645. So that is negative 1.645. So we convert this Z to a X value. So how would you do that? So X is mu plus Z times sigma. Okay, so mu here in this case, or for the mu woman's distribution, so we forgot to write down the parameters. So for the woman, the mu equals to 63.6 inches and the standard deviation is 2.2 inches. Oh, it's a long problem. Okay, mu is 63.6 plus sigma is negative 1.645 and Z is negative 1.645 and the sigma is 2.2. Okay, what is that equals to? 1.6. 60.6. Okay, it is 59.98 inches. Okay, so the new height requirement is that person has to be between 59.98 inches and 72.54 inches. Okay, so let's type this. At least, okay, start with the least one, which is we just found out that 59.98, or one decimal place. Okay, so maybe 60 inches. So 60. Okay, 60 inches, and the maximum height requirement is I think it's 72 or something like that, right? 72.5. 72.5. Okay, let's double check that. Yeah, should work. Okay, great. Now the next one that I want to do is the last question, 13. The P9. Okay, I guess this is also same as see, the P90 stand for the 90th percentile. Okay, so the 90th percentile separates the best 10% from the lower 90%. So you have the area, so you first convert the areas to okay, so you have the area, and then you have to find out the Z value, and then once you find the Z value, you convert that Z value into X value, and then you find out the answer. So it's the same as the previous question. So I hope you just follow the way I did the previous question, and hopefully you will have a better understanding when you come steps to this question. Okay, so please let me know, send me an email, or just yeah, the best way is to send me an email. So send me an email if you have any questions, or if you need further explanations. I'm more than happy to explain further. Okay, so good luck with homework 13.